So part 2 starts with examples 5, studying particle motion. Now, I'm just going to say right now, anytime you see particle motion, an equation for S, velocity, acceleration, you need the key. So if S is t squared minus 4t plus 3, take the derivative of S to get V, 2t minus 4. A is the derivative of V, which is 2. This key is going to give us everything we need. Okay? Now, displacement is the change in position. Change in position. So, the first 2 seconds, that's really from 0 to 2. I'm going to find S of 2 minus S of 0. If I plug 2 into my S function, I get -1. If I plug 0 into my S function, I need to subtract S of 0, which is 3. So my position changed by -4. Average velocity. Notice the difference between B and C. Instantaneous, that's this velocity. Instantaneous is the derivative. Average velocity is the slope of 2 points using your position function. First 4 seconds, that's from 0 to 4. So average velocity is, first of all, it's really your displacement divided by your change in time. So your change in position divided by your change in time. If you plug in 4, you get 16, you get 3. Minus S of 0, we know is 3 divided by 4. 0 divided by 4 is 0. So it's just telling us our average velocity in the first 4 seconds is 0. Now, for letter C, instantaneous velocity, that's just finding V of 4. This is your instantaneous velocity in the key. So just plug 4 in. 2 times 4 is 8, minus 4 is 4. And this is in meters per second. Our displacement should have been meters. All velocity is going to be meters per second. Acceleration. Notice the acceleration doesn't have a variable. That means there's a constant acceleration of 2 meters per second, or meters per second squared. So your motion is really just, the motion of the particle is, we'll get more into that in later, because we'll talk more about that. Let's look at, let's look when it changes direction. That's going to be a little bit more important. It changes direction. Think about like the rock problem. It was going up in the air and then it came back down. So when it's going up, it's a positive velocity. When it's going down, it's a negative velocity. So it always changes direction when the velocity equals 0. So that's something that's really important. So if we put 0 in for velocity and solve for t, it changes direction at time 2. And if we think about this, if I plug in 1 or I plug in 0, from 0 to 2, it has a negative velocity. So that's moving left or backwards. And from 2 forwards, it has a positive velocity, so it's moving to the right or forwards. So that's kind of what it's wanting us to do. And we don't need to worry about F. Okay, so the rest of this is just understanding that the derivative finds a lot more than just the slope of the tangent line. It can find sensitivity to change. I don't think I've ever seen a question though having to do with that. But this is important. Derivatives in economics, you really find calculus in every single field. In economics, it's the marginal cost. And if you go down, don't worry about the sensitivity to change part. Go down to marginal cost. The derivative of cost with respect to X is marginal cost of production. So this is all I need you to know. Basically, when you see the word marginal, you're going to take the derivative. So in the last example, they give us cost and revenue formulas. It wants us to find marginal cost and marginal revenue. So we're just going to find marginal cost is the derivative of cost, 3x squared minus 12x plus 15. So when we're selling, we're just going to calculate it for 10. So C prime of 10, we just plug in 10 and we get $195. Marginal revenue is the derivative of revenue. And then we're just going to plug in 10 and we get $252. So the big thing when you see the word marginal, just take the derivative and plug in the value.